It's all yours there.
Thank you, Adriano, and thank you everyone for joining for this session. I know everyone is busy. With COVID, we are more busy, working remote, children's at home, whatnot. So I do appreciate you taking your time and came to listen to me. This is a pretty extensive topic. I know the title said 7 things, but there was another new item went into public preview this year. So I also added it. So we'll be talking about 8 things, and there's another one in the pipeline to anytime we'll go to public preview. We'll just touch on that. Since this is a lunch hour meeting or in a working hour, if you're joining from other time zones, I will definitely finish at the hour, and I'll hang out if you have other questions. I definitely have time to answer those. I have everything you will see, including the slide of the demo code. I uploaded and refreshed my GitHub repo. So in case if we do not go through everything, you should be able to download and test those by yourself. And in that process, if you run into any issues, here is my contact on the left side. I'm not going to read my bio. Please get in touch with me if you have any questions, comments, anything, let me know. So, and I will, yes, go ahead.
Sorry about that. Just one quick note, folks, please remember this session is being recorded.
Okay. So if you, I'll send the GitHub repo to the organizers. I'll also put in the chat, download, reach out to me. I'll definitely answer your questions. So before we get into the topic, I'm going to spend probably maximum 2 to 3 minutes, talk about very high level. And this slide itself can be an hour or 2 hour talk. Because what happens when you submit a query to SQL Server Engine, unless you understand this slide and what is the issue that Microsoft is trying to solve with this family of intelligent query processing members, it wouldn't make sense, right? Unless you know what problem you're talking about and unless you appreciate that, the solution wouldn't make sense, right? So let's see why Microsoft started, this journey starting with SQL Server 2017. What are the problems that existed and why they came out with these new features? And like as I said, this is a very high level. I know there are experts, like Paul White, and there are other people. I don't want to name everyone. They can talk about this for hours. So whenever you submit a query, the first thing happens is a parsing phase. So during the parsing phase, the query is parsed into a logical tree, right? It just see that does it make sense. At this time, it even doesn't check your objects if they exist or not. It's just checking the logic that can I parse this query into a logical tree. After that, we go to the transformation phase. And during the transformation phase, the query optimizer produces equivalent variations of the tree. So it tries to find out what are other ways I can run this query or I can get to the result set, right? There are many paths because, just imagine if you have 3 or 4 tables, if you're joining, right? Your join orders can vary. So it tries all those and make sure it look at all the variations. After that, after all those variations are created, then the cardinality estimation goes into action and it assigns a cost to each operator based on the estimated number of rows. And all those costs get added, and that's how you get a total cost of that query execution. Now remember, the cardinality estimator or the query optimizer is a cost base, right? So it look at all the equivalent trees and look at all the cost, and the cheapest is the winner. And when I say cheapest, this is in terms of resource, right? And when I say resource means CPU, memory, time, everything. So whatever query I can run with the least amount of resource and the fastest will win. Once I have that query identified or the logical tree identified, that query plan get saved into the plan cache. The reason it gets saved into the plan cache, when next time I see a similar query, and how do I know a similar query? Or every query that you submit, it get turned into a hash number. Based on that, okay, someone probably is not muted, so if you can mute, that'll be great. So based on that hash, if we next time see that it's the same query, I do not have to go through those phases. I can just grab the query from the cache and then go to the execution phase, right? So this all looks good. So what happens when the cardinality estimation phase go wrong, right? And I'll touch briefly why that phase can go wrong. Once it goes wrong, now your costs are wrong, your comparison is wrong, you're not getting the optimal plan saved in the cache, and you are using that suboptimal plan over and over, right? So imagine you walk into a doctor's office or into a big hospital. What does the front desk do? Everyone comes in, same question, last name, date of birth. Last name, date of birth, right? They check you in. If you have a suboptimal plan saved in the cache, you're going to be using that over and over and over. And if a plan is getting used more frequently, very less chance that it's going to get evicted. And why a plan get evicted from the cache, there's a bunch of reasons. I'm not going to get there. But why does the cardinality estimation get wrong, right? Missing statistics, stale statistics, inadequate statistic sample rate, because we only get 200 steps in our histogram, bad parameter sniffing, out of model query constructs, table valued function, table variable X query. There can be many other reasons. And Microsoft always had this, the way it was set up, once a plan is in the cache, till it get evicted for, like I said, there are many reasons. I'm always going to use that plan, even though I know that it's not optimal, even though I know that my estimated number of rows are wrong. And it was not making any self-correction. Starting in SQL Server 2017 and compatibility level 140, I'm going to use this term compatibility level a lot. The default compatibility level for 2017 is a 140, for 2019 is 150. You can still run it in SQL Server 2019, but you can revert to an older compatibility level. If you do not know, please read about this, because when you go to Azure, there is no major version of SQL Server. There's no concept of SQL Server 2016, 17, 19. You only can control behavior with compatibility level, and Microsoft even pushing the vendors to certify their product based on compatibility level, not on the major versions anymore. So what happens when things go wrong, right? I'll highlight a few of the things. A query can execute in parallel based on your max DOP and your cost threshold parallelism setting. Or it can run serial. So if your cost is not correct, a plan that could have run serial will now go parallel or vice versa. So you have problem in both ways, right? If you're going parallel that you don't need to go, then you are using more CPUs than you don't need. Or if you're going vice versa, if you're running serial that you could go parallel, now you will be running for longer time because you could have done this in parallel. Memory grant is a big topic. Itself can be a talk. If you're granting more memory you do not need, you're wasting memory. If you give less, you're going to spill to the disk to 10 GB, and it's going to take more time. There are operations that need memory, right? Sorts, hash tables and all that. Access method, right? You can do seek scan or you can do seek plus scan. Again, just based on your estimated number of rows, you can make a wrong decision and that can hurt your query. Algorithms, what kind of join you do? Do you do a nested loop join, hash join, merge join? Aggregates, you can do stream aggregate, you can do hash aggregate. All of these are decided based on that. So
a quick note, sorry for interrupt, Taiob. Just a quick note. Are you sharing your screen?
I thought I was, unless something happened.
I do not see it. Does anybody else see the screen? Just
How about now?
yeah, now I can see it.
So you didn't see anything from the beginning?
No, I do not. I just noticed that now, but did anybody else see that?
I did not either.
Okay, thank you.
Okay,
Sorry
so
about that.
that was
not even
my
us.
mistake. Okay, so I'm just going to. So these are my contacts, but I'm sure you can get my contacts from any place. This is the slide I was talking about: parsing, transformation, cardinality estimation, compare cost, plan cache. And then I talked about if cardinality estimation goes wrong, the further phases, can go wrong. And this is what I was talking about: cost, memory, grant access method algorithm. Are we good here, or anyone want me to repeat anything? I'm really sorry about that.
Anybody want to drop a message? Just let us know.
Okay. Okay, so nobody's saying anything, so I'm just going to move on for the sake of time, and my apologies. So
yeah, they said you can continue, please. Thank you.
Great. Okay, so in SQL Server 2017, they didn't call this intelligent query processing; they call it adaptive query processing. And these features that you see I highlighted with a square, these are the one was released, and then more came in 2019, and this is the total family, and there'll be more getting added, in 2021, which I'll touch briefly. So what's the thought process here? The thought process here is now, once I'm doing the query optimization, once I'm going through these phases, if I see that, or after I executed this query one time, I know that this is not optimal. I saw there is a spill because lack of memory. Can I correct it on the fly instead of doing evict this plan and doing a full query optimization again, or coming up with a new execution plan? So that's kind of the the thought process behind it, right? And why would I do that? Because Microsoft want to be adaptive, right? So if you are sending different parameters, can we self-correct based on the parameters? If there is a join based on my outer outer table or outer the data set, if I'm qualifying many number of rows, can I go to hash join? And when I have less number of rows, can I go to nested loop join on the fly? And we'll see some of this. So that's kind of the thought process. And there were some problems that Microsoft knew, but of course, they probably didn't have time to tackle those, like with Scalar UDF, with table developed functions, with table variables, right? We know that there's a problem with the cardinality estimation because during the compilation, the engine has no idea how many rows are in the table variable, right? So some of those things they are now trying to fix on the fly without you refactoring any of your code. You do not have to rewrite your code. If you are running with with those compatibility level 140 and 150, you can automatically take advantage of this, right? So there are three guided principles by Microsoft that available by default. So when you go to the latest compatibility level, these things will be turned on automatic. And I'll show you, if you have edge case that you don't want this, how to turn this off. Improve the performance of the existing workload without without much effort to implement this, right? You just have to upgrade to new version, get to the new compatibility level. You should automatically get it. Parallel workloads improve when running at scale, right? That means remaining adaptive. So if you have a workload, that's qualifying, larger data set, and the next time is qualifying smaller data set, it should adapt by itself. So these are kind of three things that I kept in mind when doing this. You see here that under the memory grant feedback, I have batch mode and I have row mode, right? So if we go back, batch mode was released in 2017. Row mode was released in 2019. But you also see something that was released in 2019 called batch mode on Rowstore. We'll talk about this more in length, but remember, anything that qualifies for a batch mode, if your row mode operation qualifies for a batch mode, you automatically get those features. And I'll show that more when you go to the demo. So let's move on. This one, the C feedback, I only have slide. I'm not going to do this demo because this is still not in preview. This was talked about during the last PASS summit. I mean, PASS summit under SQL PASS. We are having the summit this year, under Redgate. 2020, Pedro Lopez and Joe Sack gave a talk named Azure SQL Path to an Intelligent Database. You'll find the recording. They talked about it, but it hasn't gone to public preview yet. I'm keeping an eye. I do not have any insider information when it's going to go. I'm not going to read this slide, but you will get it, read about it. Query Store Hint went to public preview this year for Azure SQL Database, Azure SQL Managed Instance. Primarily, this one will be, you can add hint to a query without having access to the code in the query. So you can get the query ID from Query Store, or there are other ways to get query ID. If you know the query ID, there are new store procedures you will see in your Azure SQL Database, Azure SQL Managed Instance, that you can pass hint to the query ID, and that hint will take effect. And we'll talk about a little bit more. This is one of the system catalog views, was released in SQL 2016. As of SQL 2019 CU13, which came out in last 2 weeks, there are 23 items into this. So even if you are at the latest compatibility level, I said you get all these intelligent query processing features by default. If you want to turn it off for certain databases for edge case in your workplace, if you need, go to here, look at these values, and you can turn it off at a database level. This one also, you can use some of these hints at a query level. So I said it's by default turned on at instance level. You can control it at a database level. You can also control it per query. So this one also has 23 values. I checked after the CU13 came out, they haven't added any. So look at those, and you can use those if you want to control the default behavior per query. Going forward, all my slides, on the right corner of the slide, right top corner, you will see this symbol. I just made those up just for the ease of understanding. So if I explained, what symbol means what, right? So let's move on. So the first one is adaptive join batch mode. So with this slide, all these have these 3 slides. I'm going to talk about what problem Microsoft is trying to solve, how they solve it, and a couple of cautionary notes, right? So this one, I think I already mentioned it, right? If you have a join hint, and on the left side, if you see I put 140 and 150, this may be not very clear to many of you. I'm not using SQL Server major version here because for Azure SQL Database, there is no major version. When you see 140 and 150 means you have to be minimum at 140 compatibility level, which only you can get to if you're on SQL Server 2017. So you need to be at that to get advantage of this. So some of these you will see only 150, or some of these you will see both 140 and 150. If you're not clear, type a question in the chat and I can explain more. So this one we talked about. The drawback that Microsoft is trying to fix is, what kind of join I get, right? And this is only between hash join and nested loop join. We're not talking about merge join here. So your query has to provide the correct result with any of these 2 joins. But now if I'm qualifying for a larger number of rows, but my estimates are low, I might go for a nested loop join. And then when the actual number of rows I look at, there's a huge number, nested loop join might not be optimal. So on the fly, based on the threshold, the query engine is going to decide what kind of join it's going to do. And how does that threshold get decided? I put an URL here. If you want to know, go and read that more detail, right? It dynamically will switch to a better join, nested loop or a horse join based on the threshold. And there are a couple of caveats. It's only good for selected statements. Of course, like I said, join needs to be eligible for both hash and nested loop join. And both joins has to have the same outer reference. And this might introduce a higher memory requirement. So I put a URL at the end to read more about this, but because now it has to check, a little bit more, few more things. So, you might end up, spending a little bit more memory. And plus, you always have to first, check the hash probe table and see, how many rows are there. Based on that, it has to decide. So, and again, this said that it is good for batch mode. But again, as I said, if you have a row mode, qualify for a batch mode, you automatically get advantage of this. And a lot of this core will get clear once we go to the demo. Table variable deferred compilation. And this is, as you see, I put here 150 means you have to be at SQL Server 2019 default compatible level 150 to take advantage of this, right? So what happened when you use a temp table? When we are using a temp table, the compilation of the statement, that reference a temp table, it is deferred until the first execution of the statement, right? That's how it knows how many records are in the temp table. Whereas when you have a table variable in a statement, it is compiled with other statements. It's not deferred. So at that point, your temp table is not populated. So the compilation only sees that there is only one row in the table variable. So that's the problem that Microsoft is trying to solve. And with table variable, there are other restrictions, right? And which I'm not going to go through. That, and if you do not know, look it up, right? There is no, there's no auto statistics in table variable, and there are other restrictions also. You cannot create index. You can only create index when you are defining the definition of the table variable and all that. So with this feature, the compilation will be deferred, and it will be same as a temp table. So during the optimization and the initial plan compilation, what it will do, if it sees a table variable, it will wait. When the table get populated, it will see exactly how many rows are into the table variable, into that table variable that you declared. It will see the exact number of rows. Based on that, it will actually compile the rest of the branch of the query, and it will optimize the downstream plan operations, right? So as I said, optimizer will delay the compilation and it will get the accurate cardinality. Now, if you have a small number of rows, this really doesn't make any difference. You probably are not going to see much improvement, but for bigger numbers, yes, you will see a huge improvement with this. And if the optimizer sees that it's a small number of rows, it will probably not change the remaining branch of the execution plan. This feature does not change other restrictions that comes with the table variable, right? And it does not fix the parameter sniffing issue, because the plan that gets into the cache, it's based on the initial deferred compilation. So it happens on the first time. And later on, if you are using the same plan, but the number of records change into the temp table, this really doesn't change the query plan any further. So if your table variable row counts vary significantly across different executions, you might not see an improvement. Multi-statement table valued function. This also had a fixed cardinality guess of 1 up to SQL Server 2012. When the cardinality estimator was rewritten with SQL Server 2014, that value of 1 was changed to 100. So still not optimal, right? 1 or 100. So you have only two options. So this is the same case with interleaved execution. What's going to happen? The actual row counts from the function will be used for the downstream query plan decision. So since this was implemented in 2017, as you see on the left, I said 140 and 150. The optimization and execution was always unidirectional, right? But with this, it changed the boundary. And what do I mean by that? During the optimization, if the query optimizer encounters a candidate that has multi-statement table evaluate function and that qualifies for interleaved execution, what it's going to do, it will pause, it will optimize, and then it will execute, it will optimize again, and then it will execute the applicable subtree, right? So, and it will resume, the downstream operations. So this is a shift that we haven't seen since till at least SQL 2016. Again, if your function qualifies for a small number of rows, probably not a big deal. You're probably not going to see a huge change. But if it's a higher SQ, yes, you're going to see improvement. There are also some restrictions. Again, it must be read-only and not part of a data modification. And you must be using runtime constant. Now, runtime constant is a big topic. I put a URL here. We just do not have time to go through it. And again, once an interleaved execution plan is cached, the subsequent execution is going to use that same number. So if your numbers are fluctuating, between the executions, you might not see the gain in every execution. Memory grant feedback on batch mode. Again, the same thing that I was talking about. If you query compiled with the first parameter value that you are passing, and it got into the cache, and then it sees that either it granted you a lot of memory that you're not using, or it granted you less memory that now you are spilling to disk, it will automatically correct itself. One thing to remember, it is not persistent. So if you fail over, if you have a reboot, it has to learn again. There is a formula. When does this trigger? I put it in the slide. And in the execution plan, there is a new property to see if your memory is getting adjusted. And I also put enough note we'll see during the demo. There are a couple of things. If your grant is under 1 megabyte, it doesn't do anything. And it also, if you have limitations set by resource governor or by query hint, those will win. And it doesn't capture into the query store. I should probably look at that statement. That's my bad. I'm going to look at it again. If it changed, I will fix it, because there was some talk about having that captured. I'm not sure yet. I didn't double check before this presentation. Same as memory grant feedback row mode. So batch mode was in 2017 in 150. In 2019, it is also now available for row mode. And when I say it's available for row mode, means only for this one, even you do not qualify for batch mode on row, batch mode on row mode, you will still get it. TSQL Scalar UDF inlining. So user-defined functions, Scalar user-defined functions has inherently, it had few problems. One was user-defined functions invoked in iterative manner, right? Once per qualifying rows, right? And this always incur additional cost because it's not, it's not doing the operation on a set, it's row by row. It also had lack of costing, because during the optimization, the relational operators get cost, not the scalar operator. So when Microsoft first wrote this cost engine, that time, scalar UDFs are not being used at a scale that it get used today, that, we run this against huge amount of rows. And it was, generally cheap and didn't require a cost. But that got changed, with that, big set of data and all the new operations and new applications and all that. SQL Server also doesn't allow queries to go parallel when you are using a scalar UDF. And the imperative code does not scale. And what do I mean by that? Imperative code, and this is another big topic. If you have a if-else statement, while loop, variable declarations, there are a bunch of these things that doesn't scale very good. So these are a couple of the problems. So starting 2019, your user-defined scalar user-defined functions can be inlined automatically. Now, does it guarantee that everyone is going to be inline? No. So I put enough URL. Please go and read about. There are a lot of restrictions. If you have these things in your functions, it cannot be inline. There is a catalog view that I'll show you, or there's a system view. It shows if your function by theory or in theory qualifies to be inline, but that doesn't guarantee it to be inline. And also in the execution plan, there are new properties to see if your function got inlined or no. This feature was based on the Deferred framework. I put a URL. If you are interested, go and read. This is a very heavy technical paper. I'm just telling you, probably not very easy to consume. Requirements to be eligible, as I put in there. sys.sql modules will tell you if your UDF can be inlined. And if you write a function today, and for some reason you know that you do not want it to be inline, without using any hint, you can actually put this in your function inline equals off. That way it will never get inlined. Just so in case if you have edge case, I wanted to mention that. Batch mode on Rowstore, we talked about many times. Batch mode was first introduced with column store indexes. And people love it because batch mode saves CPU time. And we cannot use column store index for everything. There are restrictions. Like, if you have triggers, cursors, persisted computed columns, there are many cases that, it's just not practical to use column store index. But people like the batch mode operation, right? Because it's less memory grant, it's less CPU intensive, a lot quicker. So there was a request, and finally Microsoft says, yes, there are Rowstores, means your traditional B-tree indexes can use batch mode. So this was introduced in 150. And like I said, any new feature that qualifies on a batch mode, and so if your Rowstore goes to batch mode, you should be able to take advantage of those. Again, I'm not going to read this. It won't kick in for, XML is first column set. And all that. And I put a note here, two features are independent. So do not get confused with column store and batch mode on Rowstore, right? You can still get it even on the traditional B-tree indexes, and I'll show that during the demo. Approximate approximate count distinct. Sorry, it's a tough one to pronounce. Be extra careful. This is a huge memory saving operation that you can run, but you need to know where you can use it, where you should not. If you're using if you're working in a financial industry like me, do not even get near to it, right? But if you're working on large data set that people are just looking at trends, like billions of records, people are not really worried about if it's 10 billion or 9.9 billion rows, right? They just want to see trend when things start moving in a different direction. Like that kind of analytical query, use that. You can only use it in 2019, and this is based on that algorithm that I put here. Again, very heavy and technical paper. this can reduce your memory uses or memory grant hugely, and I'll show you this during the demo. As for Microsoft, so just so you know before you use it or you suggest your developers to use it, or the analysts, that you can incur up to 2% of error rate within a 97% probability. So if someone sees more than 2% error, don't get surprised, because Microsoft didn't say that with 100% probability, right? That's why they said 97%. So you can be spilling over 2+ and get into that other 3%. Query store hint. We talked about this briefly at the beginning. This is if you have a query running, you see it's not optimal, you know something is wrong, you need immediate change without a downtime, without rewriting the code, without doing another commit, going through dev, QA, and production. Or you don't have access to the source code. Some of you might say, why don't you use a plan guide? If you read all the blog posts, plan guide is not the easiest thing to use out of all the features that Microsoft released within, for SQL Server operation improvement. So I have a bunch of examples that you can use it. I'm not going to go through it, but in a nutshell, your query get executed, you get your query captured into the query store, you get the query ID, and as I said, there are catalog views you can get query ID. Even in Azure Portal, there is something called Query Performance Insight. You can get your query ID, or you can get it from Query Store built-in reports in Management Studio, or you can get it from the catalog views. And then there is a store procedure called SP Query Store set hints. You can use that to pass a hint, and you can pass one or more hints. Remember, there are a couple of things. Query store hints will override if there is hard-coded hint into the query itself. If hints contradict, your query execution will not be blocked, it will be just ignored. Query store hints are persisted, and it will survive a restart or a failover. I talked about disabling this, so these are a couple of examples how you can disable it at a database level or at a query level. I'm not going to come back to the slide. I'll go to the demo. I don't think so we'll have time to come back. So these are a couple of things that you can read about. I'm going to be using SQL Server 2019 CU13, but I'll play a lot with the compatibility level during the demo. And because I messed up with my slide sharing, these are my contacts. Again, if you want to take a picture or anything, do that right now. And I have a thank you slide, so don't go away. I'm just showing this because I don't want to come back here. And I'm going to stop sharing for a minute. I want to share a different screen for my demo, so make my life a little bit easier. And this will be a good time to put your questions.
Tayo, we have a question here from Simon, and he's asking, the slide deck, is it available? And I believe would be on your GitHub, I think you said.
Yeah, so let's do that right now, because I don't want. Yeah, so as you can see, 1 hour ago, so I refreshed the repo. I've been working on it, for a while for this presentation. So I refreshed it just before this presentation, so you can download, do whatever you want, and send me feedback. I'd love to get your feedback. If you think, I did something wrong, I can improve, whatnot. Fair enough. Anything else?
That's it so far. Thank you very much. And folks, just check out the chat where Taiob dropped the link to his GitHub. Thank you.
Okay. So let's move on. We have 18 minutes. And like I said, you have all this. So even if I don't go through this, these are all numbered. Enough comments has been put into this. If you do this setup, which I'm not going to do, it takes about 18 minutes in my laptop because I create big tables and do a bunch of things. And I did not write many of this code. That's why I said where I copied this stuff from. Even down here, I got it from Jonathan Caha's SQL Skills. So I gave credit wherever it needs to be. So a lot of things is not mine. I copy pasted, but I made sure that I mentioned it. So, and I think that's fair, right? So, so once you do this setup, you should be able to follow all my code. And most of these codes, again, you will see at the top, I haven't wrote this myself. I copied it from here. And I did check with with Joe Sack in Microsoft, who is leading this team. I know him for many years. They actually appreciate we are talking about this in kind of this kind of settings. They want the word to get out, so they are okay using their code. And they also have a feedback email address. If you want to give feedback on this, please send it to them. And Joe actually read all this. And I have a couple of conversations with him. So I know I'm going to the last one first because query store hints is pretty new. I think it's pretty cool. This is only available for Azure SQL Database, Azure SQL Managed Instance. So I'm going to show this one for the interest of time, and then I'll go from number 1 and go down as many as we can look at, right? So for this one, what I did is I'm actually using a Azure SQL Database here. So this is Azure SQL Server, and I have a database named property MLS, right? And this was restored from a backpack, which is available in GitHub. So you can set this up. And if someone need help how to import this and whatnot, reach out to me and I can show you. We just don't have time in this presentation. In future, probably I'll just give a PowerShell functional share, a PowerShell code I'll share, so everything is automated for the setup. So we are making sure the query store is on, and its capture mode is read write, right? So now we have this Azure SQL database. In Azure SQL, just so you know, I cannot use the use statement. So I have to make sure that I'm in the right context of the database. That's a limitation of Azure SQL compared to on-premises, right? You can say use database name and you can change context. Here you cannot. So now there is a new system table that we can see, query store query hints. I go here, there's nothing. So we haven't passed any hint. And if we look at this table and look at the histogram for this stats, we see that I have one agent ID with 100,000 properties listed. All my other agents are in two digit, right? This is the one with the 6 digit. So this is a real life problem, right? People get into this, right? That's why we say parameter sniffing, because depending on what ID I'm going to use first, the query is going to get cached, and the subsequent IDs are going to use the same plan, right? So let's do this. We know that 101 has huge number, right? So let's call this and I'm turning on my actual execution plan. If some of you are not familiar, there's two different kinds. One is estimated, one is actual. I can also do it with Control M, but I'm just showing here there so you can see. Now if I run this, as you can see here, I get 100,000 rows. Here I only get 3 rows. Now look at this plan now. What happened? The first one was in parallel, and the memory grant was 12 megabyte because it has 100,000 rows. But the second one only qualified for 3 rows. But look at this. $100,000 rows only qualify for 3 rows, right? So what happened here? I only used 16 kilobyte. I was given 12,720 kilobyte. Imagine if there are subsequent, in parallel, many, connections are calling the same. What's happening? You are giving out extra memory to everyone, right? Not ideal. So I see this problem. I don't have access to the code. I'm getting other queries cannot run because there's, they're waiting for memory grant. And, that's a, very common wait type you'll see. So now what I can do, find out the query ID, which is 4. And now I can pass a hint. And I'm not touching the query itself. I said recompile it. But now, again, be careful. I'm not suggesting go and just do it. And this should be a short-term solution, right? A hint should be always a short-term solution. When you have time, when you have the cycle, you should probably put it for your next release whatever you want to do, right? You probably want to have, filter indexes, or you can have a, one store procedure, say, if you are called with this kind of IDs, then, call this one, others call this. There are many ways to solve this. I'm not going to get there. So now we pass this. Oh, sorry, I should have changed this. Yeah, I have a note to myself and I didn't follow my own note. So now we have a query hint for query ID 4. This is the query hint. And as you see here, source description is user. It might not make sense today because Microsoft is working on other stuff. I'm not going to go into details. Very soon, there will be other values that's possible to see here, but not right now. Now, I'm doing the same thing. As you see, I called here 101 and 4, calling the same thing. Now look at that. For the bottom one, I got a nested loop join. I get index seek. I get index scan. My memory grant is only 1 megabyte. And here, my memory grant is 12 megabyte. And yeah, we saw that before. If you want to remove the hint, sorry, like you solved it or you don't want to use the hint again any longer, you can just remove it. Come here, hint is gone. And if we execute this again, we'll be back to the problem that we saw at the beginning. Any question?
Checking right now.
I'm also watching chat, so there's no, but I know there's no, but I'm just asking everyone. If there's questions, please put in there. Okay, I'm going to move a little bit faster. Again, all of these were copied, from there, and then I modified wherever I needed. So you'll see this over and over because I want to show you pre and post. So I'm going to change the computable level, means I'm going to behave like 2017, and then I'll switch to 2019 and I'll show you the difference. I'm cleaning the cache. I'm not advocating this doing in production. I'm just doing this for demo, just to make sure that, I start with the new execution plan. And all of this, most of this I'll have, turn on the actual execution plan. So how could you use query store hints if you have more than one selected statements inside a store procedure? So if you want to pass a different hint for different SQL statements, Bruno? The question is, how could you use, for example, I do not know. So that's a good question. I'm going to take a note. If you can, Bruno, if you have an example of a if you have an example, send it to me, or I'm sure I can probably come up with one. I do not know. So I took a note. I will.
Sorry, Taiob, is easier. Imagine that you have a star proc with 2 select statements, and you want to put just with recompile on one of the selects.
Yeah, I do not know.
Yeah. Okay.
Yeah, I do not know to the answer to your question. So so I can definitely write something and come up with, and if I do not know, I'll go back to Joseph and ask him, or Pedro, right? So
okay, thank you.
Yeah, I do not know off my head. So okay, so Avi said each statement in an SP gets a different query ID. That's Avi's comment, probably true. I do not know, so it'll be a good thing to play with, and maybe I'll add that in my next time I present this. But very good question, I like it. Thanks. Okay, so we're going to so you see this. you probably haven't seen this before, right? In the older versions of SQL Server, or even if you are on the latest SQL Server, but if you're using old competitive level. Now you see adaptive join here, right? This is a new join type. We are used to seeing hash join, nested loop join, merge join. So what it's doing here, and as you can see, in this case, it qualified for this branch, or this got executed and nothing happened here. And if we come here, adaptive join actually did a hash join. The threshold is 68. And if we come here, our estimated number of rows were 206. So it's above the threshold. So it did a hash join. Now I'm just going to, set up some data just for demo purpose. Now I'm running the same query. I just changed the 360 to 361. And, we controlled it. I only added 5 records for 361 purposely. And this time, for a nested loop join, the threshold is 11. And my estimated number of rows is less than 10. And my threshold is 11. So what will happen in this case, it is going to do a nested loop join, and it is not going to touch the hash join. Make sense? So, and this is, for batch mode. So I'm not going to run the bottom part because, again, to prove that, which I said many times already, maybe I should show something here, and I should have done this. For batch mode, right? But because this is a column store index I'm operating on. But if I do not have a column store index, I have a traditional, B tree. It's a Rowstore, but it qualifies for batch mode. You can run this and test this. It will still, qualify for adaptive join. One other thing can happen. Depending on what is the first parameter that your plan was compiled with, based on that, you might not get it. So I created a store proc here just for demo purpose. Now, if you see that I'm calling you to 10 and then 361, right? So this one is going to get cached. And if we run this, you see that we did not get adaptive join. We only got a hash join because this was compiled with hash join. And so the second one will also, get compiled with the hash join. Why this one did not? Because this was a row mode and it did not qualify for batch mode. Now, if I evict that plan, and this is looks like a very complex code, but it's not. This is the best way if you want to evict plan for just one store procedure. Now, if I just reverse it, instead of 10 and 361, I'm going to do 361, 10. You see, I get adaptive join and I get adaptive join because now I'm using a column store index and I'm getting a batch mode. So it depends on your first one, right? How it got compiled. So table variable deferred compilation, we talked about it. Let's look at it in an action. So we're going to create some code here, declaring a table variable, inserting it, and then selecting it, right? And as you see that I purposely put it here 140. So it does not take advantage of the, no, I shouldn't. I can turn on. Didn't want that. And still running. What happened here? One. $490,000. Because of this, we get a spill also, right? Because we could not get enough memory because the estimator were too low. Now, also it couldn't take advantage of the parallelism because the estimator are too low. So now I'm going to change to compute level 150. I'm going to, change my parallelism settings so it can take advantage. Now, I'm also cleaning up the cache. Don't do it. I'm running the exact same query, no change at all. And we didn't look at the CPU time on the other one. I'm sure this will be a lot faster. You will see here, because of the deferred compilation now it knows exactly how many rows are in the table variable. It went parallel, and we do not have a spill because it got the memory that it wanted. I'm going to revert back this change for further demo. So I know we are, at the hour. Simon has a question. The SQL Server query store extracts every query statement from the query. For example, if in the store procedure multiple query statements exist, the SQL Server store will store every query statement separately. Okay.
Yeah, sorry, that wasn't a question. It was in answer
good.
to the question that was raised before.
Oh, that's fine. So now we know that. So Bruno's question was, and I'll test that, right? So, not that I don't trust you, but it'll be probably good to have it in the demo, because I'm sure, if Bruno had that question, other people will have that, right? So I'll probably add something. So we are out of time. I know I had a bunch of demos. So it's a matter of choice for all of you. I still have another 30 minutes I can hang out. I can answer questions. You can stop here. Or I can show any particular ones if people are interested to see the demo. So put it in the chat. If you have time, if you have to go for further meetings, grab some food before you go back to work, or take a walk outside, feel free. But I do appreciate, thank you for joining. And I'll be here. So if someone put in the chat, you can see all the demos that I have. Say, hey, I'm interested in seeing that one. Even if it's one person, I'll show it if you want to hang out. Or if some people say no, just continue from number 3 all the way to 7, I can do that too.
All right, folks, a great opportunity here to continue learning with Taiob. And this marks the end of the presentation, and he's going to continue here addressing your questions and displaying his examples. And remember, drop your questions on the live chat. If you're watching us after this presentation, use the comment section to drop your question.
And if anyone wants to see a particular one, for examples like memory grant feedback, Scalar UDF inlining, batch mode and Rowstore, I don't mind even if it's just one person want to say it, I can show you. At some point, I think I probably have to redo this talk just with slides and take screenshots of execution plan, because it's just going to get longer and longer with the new features coming out. So if it's an evening meeting, I can wrap it in 75 minutes, but a lunch hour meeting, I don't want people to feel like they're missing on it. So.
All right. Why don't you choose a couple there, Taiob, to show us?
Okay.
And by the way, thank you all for being here, sharing your lunchtime with us, with the great presentations here from Taiob. We have Julio saying, Taiob, my gratitude for sharing your knowledge and expertise. We got Bruno saying, thanks a lot, Taiob. And
no, I had a hold sign. I saw it says on hold, you're getting back. So I don't know what happened, but I'm going to turn off my video in case. So I'm going to continue on this one. So memory grant feedback, right?
All right.
And Adriano, you let me know if you want me to totally stop or if you see any question, I'd rather answer those. So anyway, so let's move on. So I'm going to create a store proc here, purposely setting it up. Turn on actual plan. I'm just calling that a store proc, pretty simple. As you see here, it's a where clause, order by, and we run this. There's no data in that. But if we come here, we see that we gave it, we gave it a lot more memory than it needed, right? The grant size was 67 megabyte, and it only used 920 kilobyte, right? So it's a waste of memory. And another thing I want to show you, this is a new property. Is memory grant feedback adjusted? No, because this is the first execution, right? So it didn't know what to adjust, right? Now it sees this. It says, hey, I gave you so much memory, but you haven't used it. So let me fix you up, right? And if you want to know what those values mean, I put a URL here. Is memory grant feedback adjusted can have 5 different values. And this URL will explain each one. So now we run it with a different parameter because that plan is already in the cache. It's going to use that plan because you're just calling it with a different parameter value. Now it's saying I need more memory. So it adjusts too much. You load it too much. It's not enough. And if we go to the property now, it says yes, adjusting. If you see that, still adjusting. We do a third execution. This time we don't see any warning. And if you go to the properties, not done yet, still adjusting. Do it again. Gosh, look at that now. So it took us 4. So this is what Microsoft is getting into, that on the fly is going to adjust stuff which we never had before, 2017. So now this is stable, is going to leave it there. Let me just show the last one. So then we'll call it a day. This is, if some of you are working with, with the BI, BI space, large data set, mostly analytical, like don't use it for a bank. You will not like it. So as you see, I say count, I say approximate distinct count, and here I'm turning off batch mode purposely just to see that nothing else interfere. And I'm also going to let it do the batch mode. So if I run all these 3, yes, Simon, I saw your comment. Yes, we'll do that one. Simon wants to do the Scalar UDF one, so I'll do that. As I said, if even one person wants to see it, I'm here. So, but be careful with this because the results will differ. So you don't want to do it for a company, like that deals with money or people's personal thing. You want to be exactly, you want to be accurate, right, to 100%. So this is not for that, as I said many times. So let's look at the plan. First thing, the first one, we needed how much memory grant? 1462, so more than a gig. Look at the second one, only 40 kilobyte memory grant. Third one, a little bit more, right? In between, because now we are taking advantage of batch mode. So you have to be careful. But if you go to the properties, it took 27 seconds of CPU time, 14 seconds of CPU time, 6 seconds of CPU time. But here we need more memory, less memory. So you decide, what you want to do. And the result on the middle one, so this is the accurate count. This is something in between. This is the approximate distance count with row mode. And if you do the math, it's 2.6%. You remember I told you in the slide, Microsoft has it at 2% with a 97% probability, right? So be careful with that. So Simon wanted to see the Scalar UDF inlining. Okay, good. So again, so I'm at 2019. I'm creating a function. Is my function theoretically qualifies for inlining? Yes, inlineable. Turn on the plan. Now, I could have gone to an older compatibility level to show you pre and post, but I'm not doing that. I'm just saying, I also wanted to show how to use the hint. So now I'm saying, do not use inlining. Now, if we see this, right, it looks pretty good, right? It's 100% is scan. You really don't see what's happening with the user-defined functions. And now I'm taking out this hint, running the same one. Look at the plan now, because it got inlined. And I also want to show you something else here. How do I know that this one didn't get inlined? Of course, I have the hint, but there is another thing that I want to show you. If you ever wonder, my query is running longer, is it due to the function or no? We didn't have these two things before, and I love it. Because my total CPU time was 416. The whole time was spent on the user-defined functions. And when I run this, there are two things I'll show you. One is here, you do not see that UDF runtime. And there's another new attribute. Of course, by looking at the query plan, it's obvious that it was in line by looking at the shape, but this also confirmed you that this was in line. And there are a lot of restrictions. There are a lot of things that doesn't qualify. Like I put URL, you can read about that. So Simon, hopefully that's what you wanted to see. And so I'm going to end here, but I'll hang out for any further questions, comments,